Hello everyone. In this video we are going to talk about chapter 5 lesson 4, sum and difference identities. This is page 336. The objectives of this lesson are number 1, evaluate trigonometric functions using sum and difference identities. Number 2, solve trigonometric equations using sum and difference identities. Okay, so first let's see what are the sum and difference identities. So we have 3 identities, or 3 for sum and 3 for difference: sine, cosine, tan for sum and difference. So sine a plus b here, it is equal to sine a cosine b plus cosine a sine b. Sine a minus b is sine a cosine b minus cosine a sine b. While cosine a plus b is equal to cosine a cosine b minus sine a sine b. Here the plus sign changes into minus. Cosine a minus b, cosine a cosine b plus sine a sine b. Also here the minus sign changes into a plus. Okay. Tan a plus b is tan a plus tan b over 1 minus tan a tan b. Tan a minus tan b equal tan a minus b is equal to tan a minus tan b over 1 plus tan a tan b. Okay. You don't have to memorize these identities. They will be given to you during exams or tests. Okay. Now let's see how we can use, or what's the benefit of these identities in evaluating some trigonometric expressions. So example number 1, find the exact value of each trigonometric expression. And the first trigonometric expression is sine 15. So the question is to evaluate the sine of this angle, 15 degrees. As you notice that here on the unit circle we don't have the 15-degree angle, so we cannot just simply figure this out from the unit circle. But by using the sum and difference identities, we can find another way other than the unit circle. And by saying that 15 degrees, or by writing 15 degrees in terms of two other angles that are part of the unit circle, like the 45 and the 30. If I take 45 degrees minus 30 degrees, they will, this would be 15. And if I take the sine of those two, sine 45 minus 30, technically it's the same as sine 15. Now sine a minus b, this is here we can apply the difference identity for sine. It's of the form sine a minus b. Sine a minus b. And sine a minus b, what is it equal to? Let's check back here. Sine a minus b is equal to sine a cosine b minus cosine a sine b. So let's write this down here. Equal to sine 45 sine cosine 30 minus cosine 45 sine 30. Okay. Now we can use the unit circle to find the values of those expressions. Sine 45 degrees, sine 45 is the y value of this point, radical 2 over 2, times cosine 30. 30 is here, cosine is the x, times radical 3 over 2, minus cosine 45. 45 is here, cosine is the x, radical 2 over 2, sine 30 is 1 over 2. So now we have those two fractions multiplied. We multiply numerator by numerator, denominator by denominator. So radical 2 times radical 3, this would be radical 6 over 2 times 2 is 4, minus the same way radical 2 times 1 is radical 2 over 2 times 2 is 4. Now here we have subtraction of fractions. When you subtract fractions, we have to make sure that the denominators are the same. Here they are already the same, so I take common denominator 4 and we write the two numerators, or the in the same fraction. Radical 6 minus radical 2 over 4. And that is the exact value of sine 15 degrees. Okay? Let's take another example. Let's say we need to find the tan of 7 pi by 12. Seven pi by 12, I guess it's more convenient to change this to degrees. 7 pi by 12. If we need to change this to degrees, I multiply by 180 and divide by pi. This would be equal to 105 degrees. So tan 7 pi by 12 is the same as tan 105 degrees. Now we have to, again, 105 degrees is not on the unit circle. So how can I write 105 degrees? Or what two angles add up to 105, or the difference between them is 105, such that those two angles are on the unit circle? So one option is to take 105 as the sum of 60 and 45 degrees. 60 plus 45 is 105. And now we have the sum identity for tan. Tan A plus B is equal to, let me write this here, tan A plus B is equal to tan A, tan 60, plus tan B, tan 45, over 1 minus tan A, tan B, tan 60 times tan 45. Alright. Now, what is tan 60? Tan 60, as you all know, is the sine 60 over cosine 60. Now, what's sine 60? We go to the unit circle. Cosine 60 is, sine 60 is radical 3 over 2. So radical 3 over 2 over cosine 60. Cosine 60 is 1 over 2. What is radical 3 over 2 over 1 over 2? Is radical 3 over 2 times, we flip this fraction, it will be 2 over 1. Radical 3 times 2 over 2 times 1, this would be 2 radical 3 over 2, which is radical 3. Okay, so tan 60 is radical 3 plus tan 45. In the same way, we take sine 45 over cosine 45. Sine 45 is radical 2 over 2. Cosine 45 is also radical 2 over 2. So radical 2 over 2 over radical 2 over 2, this would be simply 1 over 1 minus radical 3, which is tan 60, times tan 45 is 1. So is equal to radical 3 plus 1 over 1 minus radical 3. Now, this fraction is not in the simplest form. To make it in the simplest form, we have to rationalize the denominator. And to rationalize the denominator, we have to multiply by the conjugate of 1 minus radical 3. The conjugate of 1 minus radical 3 is 1 plus radical 3, up and down. Okay, so radical 3 plus 1 into 1 plus radical 3, 1 minus radical 3 into 1 plus radical 3. Distribute, radical 3 times 1 is radical 3, radical 3 times radical 3 is radical 9 or 3, plus 1 times 1 is 1, and 1 times radical 3 is radical 3, over 1 minus radical 3, 1 plus radical 3. This is of the form a minus b into a plus b. So it would be a square, 1 square is 1, minus b square in radical 3 square, which is 3. Radical 3 plus radical 3 is 2 radical 3. 3 plus 1 is 4, over 1 minus 3 is minus 2. I can take common factor in the numerator, 2. So I will be left with radical 2 plus 2 over minus 2. I can simplify here 2 with the 2. Don't forget the minus in the denominator. This minus in the denominator, I can put it up. So this would be, let me just erase here. And this will be equal to radical 3 plus 2 over minus 1, or I can put it minus into radical 3 plus 2 up. Yeah, minus radical 3 minus 2. That's the answer for tan 7 pi by 12, the exact value of tan 7 pi by 12. Okay, I hope that this video was clear, give you an idea about evaluating sine, cosine, tan of angles that are not part of the unit circle. And finally, I want you to try to do those two other examples, guided practice. Find the exact value of cosine 15 degrees and sine 5 pi by 12. Okay? So, this video is over. Try to answer those two questions and see you in the next video. Thank you very much.